So we've now learned all we need to about probability. We've learned about a simple event, which is one event. And then two or more events can either be independent or dependent. Independent means that every time you do something, it does not change, where dependent, it will change. This is a review over everything that we've learned. And what you need to do is make sure that you try the problem first. After you do the problem, then you're more than welcome to check it. If you get the answer wrong, then you need to go ahead and fix it. Number 1 through 4 will be answered using this fishbowl right here. So in this fishbowl, you have letters A, B, and C. Number 1 says, what is the probability of pulling a B? In here you have 1, 2, 3, 4 B's. This is going to be a simple event because all you're doing is pulling one B, so you're only going to have one fraction. Then you have 4 out of 1, 2, 3, 4, 5, 6, 7, 8. So you have a 4 out of 8 chance of pulling a B. But if you notice here, 4 out of 8 is not listed anywhere. So if you convert this to a decimal into a percent, 4 divided by 8 is 0.5, which if you move your decimal 2 places to the right, you end up with 50%. 4 divided by 7 is 0.57, so we know it's not that one. B is 3 divided by 7, which is 0.42, so it's not B. 1 divided by 2 is 0.5, which is the same as 4/8, and that's 50%. So the correct answer for number 1 is C. Number 2, what is the probability of pulling an A or a C? Here, if you think about it, you're only pulling one time, and you're happy if you pull either an A or a C. So this is a simple event. It's only going to be one fraction. So you're going to pull either an A or a C. So there's 1, 2, 3 A's. There's 1 C, so there's a total of 4 out of 8 that you would be fine with as far as pulling them. So there's a chance of 4 out of 8, which again is 0.5, 50%. And again, looking at your answer choices, we know that 1/2 is 0.5, which is that 50%. So the correct answer for number 2 is B. Number 3, what is the probability of pulling an A and a B without replacing? So here we see the word and. So what is the probability of pulling an A and a B? So we're going to have two different events, which means we're going to have two fractions that we're going to multiply together. And we're not going to replace them. So without replacing them, that means that the second one is going to be different from the first one. This is a dependent event. So the first time, what is the probability of pulling an A? Looking at our bowl here, we have 1, 2, 3 out of 8. So we have a 3 in 8 chance of pulling an A. But then what happens is we pull that A out. We do pull that A out. So we get this A and we pull it out. So we no longer have this A in there. The probability of pulling a B is 1, 2, 3, 4. The B's didn't change, but instead of there being 8 in here, now there's only 7. So we have a 4 in 7 chance of pulling a B, because you're only pulling one A out. So 3 times 4 is 12, and 8 times 7 is 56. Converting it to a percent, your answers are percents. 12 divided by 56 is 0.21. Move your decimal 2 places to the right, and you end up with 21%, which is B. Problem number 4. What is the probability of pulling an A and a B if the balls are replaced? So again, you see the word and, which means that you're pulling more than once. You're going to pull an A and a B. That's pulling twice. You're going to have two fractions that you're going to end up multiplying together. This time, though, they are being replaced, which means that it's independent. It's once you pull the A, you're going to put it back, and then you're going to pull the B, so it's not going to change. So pulling an A here, you have a 1, 2, 3 out of 8 chance. So the probability of A, looking down here again, is 1, 2, 3 out of 8. So there's a 3 in 8 chance. Now we're going to go ahead and we're going to pull this A out, but then we're going to put it back. So we end up having the choices the exact same the second time. Then to pull a B, you have a 1, 2, 3, 4 in 8 chance there. So you have a 4 in 8 chance of pulling a B, because this is an independent problem in that it doesn't change. You had 8 the first time, you had 8 the second time. So 3 times 4 is 12. 8 times 8 is 64. 12 divided by 64 is 18.1875, which ends up being 18.75%. So this 7 makes that 8 round up to a 9, so it's a 19% chance. So it's B. Oops, sorry. Problem number 5, we're going to go ahead and use this spinner and this coin. So spin the spinner, then toss the coin. Number 5, what is the probability of spinning a 4 and tossing a heads? Again, there you have the word and. So we're going to have two different things that we're doing, which means we're going to have two fractions. We're spinning a spinner and tossing heads. So first, the probability of spinning a 4, there's 1 out of 4 choices. So there's a 1 out of 4 chance of spinning a 4. Then what's the probability of tossing a heads? There's 1 heads out of 2 sides. This is an independent event because nothing changes. When you spin the spinner, it doesn't change your coin, so this is independent. So 1 times 1 is 1. 4 times 2 is 8, so you have a 1 out of 8 chance, and you say this right here, it's already as a fraction. So the correct answer is D. Number 6. Problem number 6 says calculate the probability of not spinning an A. So calculate the probability of not spinning an A. So here we have 1, 2, 3 A's out of 1, 2, 3, 4, 5, 6, 7, 8. So if there's 8 of them and 3 of them are A's, that means 1, 2, 3, 4, 5 of them are not A. So that's going to be 5 out of 8, and we see that it's C. Number 7. Number 7 says use the 2 spinners on the left to calculate each probability. So we're going to use these 2 spinners here. So what's the probability of spinning an A and an A? So we're going to spin an A on this one and an A on this one. So since we're doing 2 things, we need 2 fractions. The probability of spinning an A on this one is 1 out of 3. And the probability of spinning an A on this one is 1 out of 4. So 1 times 1 is 1. 3 times 4 is 12. So you have a 1 in 12 chance of spinning an A on this one and an A on this one. Number 8. A person has 5 cards numbered 10 through 14, and what usually helps me is if I write it out. So 10, 11, 12, 13, 14. So you have these 5 cards numbered 10 through 14. What's the probability that you're going to pick a 12? There's 1 12 out of 5 cards, so it's a 1 in 5 chance of pulling a 12. Number 9, a cube is rolled. What's the probability that's going to land on a 2? You're just going to roll it 1 time, so you're only going to have 1 fraction. There's 1 2 on a cube out of 6 sides, so you have a 1/2 chance. And this, I'm sorry, yeah, 1/6 chance, not 1/2, so it's A. Number 10 says your name is written on a card and mixed in with 9 other cards with other students' names for a total of 10. So you have 10 cards and one of them has your name on it. What's the probability that your name will be drawn? So you have 1 name out of 10 cards that are in the bucket, and so you have a 1 in 10 chance. Number 11 through 13 is going to be answered using the spinner here. Use the above spinner to answer the problems. The spinner is spun once, so because it's being spun once, we're just going to have 1 fraction. What's the probability that it lands on a C? You have 1 2 out of 1 2 3 4 5 6 7 8. You have a 2 in 8 chance that it's going to land on a C. And you don't see 2 8s here, but if you change this to a decimal, 2 divided by 8 is 0.25, which is 25%. Then if you change all of these to decimals into fractions, 2 divided by 9 is 0.22, so that's not that one. This one's 22%. 5 divided by 8 is 0.62, so that's not this one, it's 62%. 2 divided by 4 is 0.5, this is 50%. And then 1 divided by 4 is 0.25, it's 25%. So this matches 2/4 simplified is 1/4. So the correct answer is A. Number 12, the spinner is spun twice. What is the probability of it landing on a B both times? So we're doing it twice. We're going to spin it twice. So because of that, we're going to have two fractions. The first time we spin a B, we're going to have 1, 2, 3 out of 8 chances. When we spin it once, it's not going to change. A spinner's not going to change, so we still have a 3 out of 8 chance. It's an independent event. So 3 times 3 is 9. 8 times 8 is 64. 9 divided by 64 is 0.14. Move your decimal twice to the right, and you end up with 14%. So the correct answer here is D. Number 13, the spinner is spun. What is the probability of it landing on an A or a B? Here we're not spinning it twice, we're just spinning it once, and we're happy if it lands on either an A or a B. So there's just going to be one fraction. So we need to see how many A's and B's there are together. So you have landing on an A would be 1, 2, 3. Landing on a B is 1, 2, 3. So an A or a B would be 3 and 3, so 3 plus 3 is 6. So there's a 6 in 8 chance of it landing on an A or a B. You don't see 6/8 here, but if you go ahead and change that to a decimal, 6 divided by 8, you end up with 0.75, which is 75%. So looking at our answer choices, 1/2 we know is 50%. 7 divided by 8 is 88%. 3 divided by 4 is 0.75 or 75%. So since this is 75% and this is 75%, the correct answer is A. Number 14, a coin is tossed once. What is the probability that it will land on heads? So we're only flipping it once, so you only have one fraction. And heads is 1 out of 2. 1 divided by 2 is 0.5, which is 50%. So the correct answer is D. Number 15, a coin is tossed 3 times. What is the probability that it will land on heads all 3 times? So we're going to flip it 3 times, which means that we're going to have 3 fractions, 1, 2, 3. We're going to multiply those 3 together. So every time you flip it, it's going to be a different fraction. A heads all 3 times. The first time you'd have 1 out of 2. The second time you'd have 1 out of 2. And the third time you'd have 1 out of 2. So 1 times 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. So you have a 1 in 8 chance of flipping a coin and it landing on heads all 3 times. Number 16, a bag has 7 red marbles and 6 blue marbles. You pick one, and without replacing it, you pick another. What is the probability of picking 2 red marbles? So you're gonna pick twice. So you're gonna pick twice. So you're gonna have 2 fractions, but you're going to pick the first one, and then you're not going to replace it, and that's without replacing. What's the probability of picking a red, and then without replacing, it's another red? So you start off with 7 red and 6 blue. So you have 7 out of 13. But then remember, when you pick 1 red out of here, you're going to end up with 6. So then you have a 6 out of, there's no longer 13, there's only 6 red and 6 blue, so you end up with 6, 12. So 7 times 6 is 42. 13 times 12 is 156. So 42 divided by 156 is 20.269, which this 6 rounds that 9 rounds that 6 up, so it's 27%. So the correct answer is B. Number 17, what is the probability? Number 17, what is the probability you will pick 2 blue marbles in problem number 16? So we're going to go back up here. So what's the probability that you'll pick 2 blue marbles without replacing them? So again, starting over, we had 7 red marbles and 6 blue marbles. So we're going to pick a blue marble to begin with. So we're going to have 2 fractions. You have 6 blues out of 13. Then we're going to take one of these away. We're going to take 1 blue marble away and end up with 5. So now we're going to end up with 5 blue marbles out of 12 total. So 5 times 6 is 30 over 13 times